Ultimately, we believe that technology doesn't solve problems, people do. And I want to talk you through one of these people. So this is William. At the age of 14, he had to leave school because his parents couldn't afford to send him anymore. He kept up his education by reading books in a local library. And there he found a book about wind turbines, and he decided to build his own. This wind turbine you see here is made out of bits of an old bicycle, some bits of bamboo, and metal. And he was able to use this to generate lighting for his family. We believe that people like William are the solution to the problem of access to electricity. But people like William don't just appear, they need support. And to support them, we've created the LE1. The LE1 is able to draw power from anything that creates a voltage. That can be a solar panel, or it can be an old motor. This one's coming from a blender, but it can also be from an old washing machine or from a car windscreen wiper motor, literally anything. You then hook it up to the input terminals. Now, if you were to just hook this motor up to your mobile phone, you'd probably blow it up. But we take that unregulated voltage and turn it into safe power, which can then be used to charge your phone or to provide lighting.
The way in which we're producing energy at the moment is not sustainable. And so we need to be thinking about new ways in which we can be generating electricity. And not only that, but a billion people worldwide over a billion people worldwide don't have access to electricity. The Global North were the ones who were creating all of these technologies. They were the ones who had control of that technology. And so they were then exporting that to the Global South. And that, to us, seemed like a power imbalance that if we wanted to have a more equal world, that we need to redress. At the same time, you have people who have amazing skills, people who know how to build their own houses using the resources that they have around them. And so we also think that there's a lot to learn from communities, particularly in rural areas. We're trying to flip that power balance on its head and actually say, well, why can't the Global South also be producing these technologies and have the potential to change the way in which we interact and use energy across the world? I decided to become a social entrepreneur for a couple of main reasons. Personally, I had a connection to, in particular, sub-Saharan Africa. So I'm of Afro-Caribbean heritage. And so there's always been this personal connection that I've had to the continent, as kind of lost in the mist of time that connection may be. I've always had a desire to work, on the continent. And then at the same time, I'm also really passionate about energy. And energy is a massive enabler in terms of what it is that you can do with it. It's a really big multiplier in education. So when you have access to electricity, you improve your educational outcomes. Students are able to study after dark. It also facilitates, particularly in the modern world, communication, which allows people to access a whole range of different services. So I've got a mechanical engineering by background, and I have been kind of working in the kind of development sector. And then in my master's thesis, I was looking at thermoelectric generators being used in Kenya to generate electricity for decentralized applications. And one of the things that I came across in the literature and also experienced myself was the problem of trying to design a solution for other people who were living in a very, very different context. So for my master's project, we were 6 students working on this project, and at the end of the project, there were some issues that we couldn't have really foreseen. In particular, looking at the way in which people were likely to use the product within their homes. We weren't really able to take those things into account. We were very focused narrowly on the technical. And what we kind of found actually was that this was a problem that was going on across kind of the development sector, where people were designing solutions and then finding that, you know, in particular when it came to maintenance, there were issues. So, for example, you know, there are pumps that are widespread across sub-Saharan Africa that break, and then no one knows how to fix them, and they just sit around essentially completely useless. And so this was the kind of core problem that I kept on seeing. And so what I tried to do was develop a product that allowed people who faced those problems to you know, in particular, we were focusing on renewable energy access, giving them the tools that they could go out and actually solve that problem for themselves, so that they weren't having to rely on external agencies, but I think more importantly, able to design better solutions because they had a better understanding of the context that they themselves were living. When we kicked off this development, the initial product was something that was able to harness energy from old motors and using them as generators. So that was in March 2017. When we then actually went out to develop and test that product, what we quickly found was that people really wanted to understand how the electronics within that product worked. And so, yeah, we created what we then called the LE1, which was this educational charge controller.
The LE1 is a new platform for students who want to learn about electricity generation and conversion. We took a fully functioning charge controller and redesigned it so that students could learn about how it works. This includes learning about voltage regulators, electrical protection circuitry, and how to program a microcontroller. The LE1 is unique in that it can take power from anything and convert it into USB power. Here we have a recycled motor hooked up to the LE1, which powers a USB light. This recycled motor came from a blender, but it could have come from anywhere: a car alternator, an old drill, or even an old fan. Now all we need to do is turn the motor and we're generating electricity. In this video we're using a hand crank made from old PVC pipe to turn the motor, but you could hook the motor up to a wind turbine or a water turbine. The possibilities are endless. Through a series of workshops, students will learn how this system works and can then use the LE1 as a platform for creating their own electricity generators. Check out this wind turbine students made in Tanzania using the LE1. Students will also learn how to program a microcontroller to display power readings on a screen, which they can then use to improve their generators.
Off the back of that, we then were able to create a educational program that kind of sat around that, and we launched that fully in October 2019, where we started training young people. Then we received grant funding from Innovate UK to then develop our smartphone app, which we've been developing for the last year, and in July 2021 we're going to be launching that smartphone app and connected hardware. Our main product is called Energy Makers Academy, and it is a mobile learning platform and a piece of connected hardware that teaches students how electricity systems work. So this is the actual hardware here itself. So this is a fully functioning charge controller. At the top here, you simply connect a battery, or in what is more often the case, a solar panel, and it then turns this into power down here for these 3 USB ports. And so that actually teaches students how a solar home system works. Within our app, what we do is we actually provide educational content that teaches students about how the charge controller works, but it also has a programming experience. And what that means is that students can write simple programs for their charge controllers, which then allows them to develop projects, but also to develop simple home automation. So, for example, you can hook up a sensor that is able to detect when it's dark and then automatically turn on a light. One of the projects that we have been supporting is a group of students from one of our cohorts that we trained is working on elephant and hippopotamus detection to protect their crops and to reduce human and animal conflict. We ran a pilot program with an organization called ZioHub, who produce, they have a kind of rural education hubs. And at the end of that training, we then asked students to think of projects that they would like to work on. And we then provided a little bit of additional support with components for them to develop the project. And one of the problems that came up was the fact that elephants and hippos were coming and eating crops. And this led to human-animal conflict, and very sadly has led to a fair number of deaths within the community. And so what these students wanted to do was to take what is a component called a kind of seismometer. So they were able to tell when there were kind of heavy footsteps coming, and they were also setting up tripwires that they were looking at, so that they could detect when there were animals coming. And the idea was then that they would then turn on a bright light and also make noise to try and scare off the animals when they were coming at night, and also to alert people that the animals were in the fields as well. So that's something that's ongoing, that is being developed within that educational hub in a rural area in Zambia. We chose Zambia for a couple of different reasons. So the first one is Zambia has one of the lowest electrification rates on the continent. So there's a lot of work to be done there. It's a relatively nascent solar market, so it's not completely saturated like Tanzania and Kenya. What we also had there was personal contacts. So I had a friend there who was working at a school and was able to provide us with our first customer. So working closely with a friend who was working at a school as a physics teacher. And the final one was my co-founder Granville, who was initially into robotics. It's been a kind of really amazing journey to kind of link up with Granville and build the company together. The problem that we're trying to solve with our product was that when we went to rural areas, we were working in Tanzania at the time, what we found was that there were a lot of these solar home systems, and actually solar lanterns as well, that were broken. And what's interesting about that is that the solar panels themselves were actually still fully functional, but it was the electronics that no one knew how to fix. They break and no one knows how to fix them. And so what we found was that there was this really big demand for understanding how those energy systems work. And in particular, there was a really strong incentive because people had taken out loans, and we're talking about really quite poor communities here. So one of these solar lanterns costing $10, that was something that they would need to take a loan out in order to purchase. And then after 3 months, it was broken. Sometimes they would take it home from the market and it was instantly broken. And so even just traveling to the market and back was a significant financial burden. So I think that what we were trying to do with our product was trying to give people that ability to fix those systems, to understand them, and then once they've understood them, to be able to create new products and new ideas and new projects based on that knowledge. When we first started working in Zambia, we were working very closely with technical colleges. And the reason for that was that there were a lot of young and passionate people at the technical colleges who weren't really getting access to the kinds of skills and materials that they needed, in particular when it came to the solar energy space. But in order for us to really innovate, we had to be running those programs ourselves. And so December 2019, we ran a series of programs through which we've trained about 130 students. In this particular context, is that you not only teach things to people, but they actually get something that improves their standard of living significantly. They actually get access to electricity. And, I think that what's really interesting about that as well is that, they say necessity is the mother of all invention. Well, necessity is also the mother of all learning. And so providing students with a very clear link between what it is that they're learning in the classroom and a problem that they themselves face and that their communities face has been really powerful in the way in which we can actually get more students involved. And it's actually been a really powerful message that has brought more women onto the program because of that tangibility.
My name is Florence Lungu. I'm 19 years old and I come from Lusaka. Where I come from, we have a challenge of load shedding, so it's difficult to do basic things such as charging my phone, cooking, lighting for studying. In order for me to find a place where I can charge my phone, I would go to a market quite far from my place and charge my phone. Then after some hours again, my phone will be off, meaning I have to go back. So you have to schedule for using electricity. I want to make electricity available to my household.
So yeah, when it comes to social entrepreneurship, and actually entrepreneurship as a whole, funding is one of the single hardest things to get right and to be able to do. I mean, we got our first bit of funding from Bethnal Green Ventures, who have been absolutely amazing. They're a really, really amazing accelerator program. And so, being part of that was fantastic. But prior to that, I must have written, 20, 25, 30 applications for funding and not gotten anything. So a lot of it is about perseverance. It's about resilience. It's about iterating on your ideas constantly, because more often than not, you won't actually get any feedback. And so trying to understand what it is that you've done wrong is actually really, really difficult as well. So yeah, I think it really is just about continuing to push on and believe in your idea. It's a constant slog and challenge to be able to do that. What we did find after we got our Bethnal Green Ventures funding, trying to get follow-on funding was a real challenge. And so we decided to go down the crowdfunding route. So we raised, our first crowdfunder raised about just under £48,000. And our second crowdfunder, we raised just under £120,000, which went alongside £184,000 from Innovate UK. So the crowdfunding is a lot of work. It's the campaign that people see live on the page is just the tip of the iceberg. The main game about crowdfunding is getting people to look at your page, and that's really, really difficult. And that's where you really need, if you have marketing prowess with someone who can really get people to click on those links. We actually found that email was really effective. People are much more likely to click on links in emails than they are on Facebook or social media. And so that kind of like content driven marketing was really important to us. What we also found was that finding lead investors is also a really, really big challenge, and one that we never really quite solved. I think you've always got to think about it in terms of leverage, and the ways in which the money that you've raised you can leverage to raise more. And in that instance, what we were able to do is we were able to use the crowdfunding our first round of crowdfunding to pay for a grant writer, which then got us a significant amount of money. And then with that money, we then went out and raised another crowdfunding raise. I think always, whenever you get any kind of money in, and this is definitely a trick that we missed with Bethnal Green Ventures, always be thinking about, okay, how can I use this money from the next round of fundraising? In terms of our business model, what we initially tested out was B2B. So we were initially selling our kits to technical colleges, and we had some success there. We then switched to a B2C model so that we could kind of get closer to the to our users and start generating revenue with slightly shorter timelines, which we were finding with the technical colleges, those timelines were significantly extended. And we'll most likely, when we kind of finally launch this product in July, we will be keeping a B2C element. But what we've also discovered is that working closely with the government is really important. B2G or B2G2C model, whereby the government will buy our kits and then sell those on to students or provide bursaries to students. An important part of our business model as well has been trying to bring on board CSR programs so that they can provide bursaries in particular to students who wouldn't normally be able to attend these programs. It would be business to beneficiary, would really be the way in which we would kind of model that rather than a direct customer. And what we're now working with various government ministries is to try and update the national curriculum around electrical and electronic engineering to include some of the subjects that we're covering in our program. The Ministry of Higher Education in particular has been someone that we've been talking to and working with in order to roll that out. And so what we've also been doing is bringing different stakeholders to the table, in particular people and corporates who have large CSR budgets, and looking at ways in which we can leverage those CSR budgets in cooperation with the government in order to deliver these programs to students from rural areas who would otherwise not be able to afford to attend these programs. Trying to sell things to governments is really challenging. And so what we've been working on as part of our project and the sales process is we kind of see the government as a distribution partner. And so what we're looking to do there is bring together a consortium which would be backed by the Zambian government, but also backed by larger corporates who have significant CSR money to spend, and bringing that funding into the government and allowing those students who wouldn't normally be able to access the program to access it. So yeah, it's a win-win situation for the government. To me, the single most important one is working with people on the ground. What we found is that there are a variety of different competitions that governments run. So in Zambia, it's the Youth Innovators Fund. In Kenya, it's Young Scientists Kenya. You've got Young Scientists Tanzania. So there are a lot of these youth competitions that are run by government agencies. I think that's definitely been a really important part of our success. Our aim is to roll out across Zambia by 2025, and to have 110,000 students every year learning how to design, build, and maintain a renewable energy system that can provide them with all the energy that they need. So we've got a couple of different places on our radar. At the moment, we're really just focusing on our product launch in Zambia. Once we've done that, we'll kind of have a much better idea about how we would launch in a new market as well. Our kind of long-term vision is about providing people with the tools and knowledge they need to create new ways of generating, storing, and distributing energy. So we really want to be part of that journey, particularly in sub-Saharan Africa, and looking at ways in which we can support young people to actually go out and solve the problem of access to electricity, but also contribute towards a zero carbon energy system. The first step on that journey is to be able to provide students with the skills and knowledge they need to do that. What we're looking for in the future is to be able to incubate the next big thing in energy, not just in sub-Saharan Africa, but globally as well.